we want to apply what we know about inverse functions from algebra to our trig functions. Here we have the graph of sine, and we see that it is not one-to-one. If we were to reflect this graph around that line y equals x, if we look at the inverse, we see that the inverse is not a function. The inverse would not pass the vertical line test, and that is because f, the sine wave, does not pass the horizontal line test. So we will restrict the domain of the sine wave. So here I'm just going to restrict the domain. I'm going to have it start at negative pi over 2. And I'm going to have it end. So you see it's still not one-to-one. So I'm going to have it end as soon as it will pass that horizontal line test, which looks like it would be at positive pi over 2. Now when we look at the inverse, we see that the inverse is a function. Let's zoom in a little bit. So here is the graph of f in blue and the graph of the inverse. And we see that the output and the input for the inverse function, so the input for the inverse function would be from negative 1 to 1. You can see that that would be the domain from left to right of the inverse function. And the output, or the range, comes from minus pi over 2 to positive pi over 2 as the output for that inverse function. In order for the sine function to have an inverse, we would first consider the original sine function. If I actually looked at the complete graph, that it would not be one-to-one. It would not pass the horizontal line test. So we want to make it one-to-one. To do that, we're going to restrict the original domain. I'm not going to use the entire graph. I'm only going to use the graph from negative pi over 2 to positive pi over 2. So we're going to restrict the domain to go from negative pi over 2 to positive pi over 2, which of course is the same thing as negative 90 degrees to positive 90 degrees. We're considering these angles right here to be negative angles. So we start at 0 and we go in the negative direction to find those angles. And this is quadrant 4. And then quadrant 1 would be this portion here from 0 to positive pi over 2. This is what we would call our inverse function. So the inverse function, that's sine inverse of x. We also use the word arcsine. Arcsine is the same thing as the inverse, so these words mean exactly the same thing. When I restrict my domain and then I switch all the x and y values, now that we see that the inverse is actually a function. The output values are negative angles from quadrant 4. We have looked at the graph here in radians, so the output in radians, but let's look at the output in degrees. Minus pi over 2 is the same as negative 90 degrees. Positive pi over 2 is the same as positive 90 degrees. So we can see that the output for the inverse function, the sine inverse function, would go from negative 90 to positive 90. We're thinking about the output here coming from quadrant 4 in terms of negative angles, and then here the output comes from quadrant 1 in terms of positive angles. The original function has a restricted domain from negative pi over 2 to positive pi over 2, and the output values were sine values from negative 1 to 1. Well, now we're going to switch that around. Since we're talking about the inverse function now, the original domain, that restricted domain, will now become the range. These are the output values. And the original output values now become the input values. So the domain and ranges now switch places. When we put something into the inverse function, any sine value, the angles that come out will come from quadrant 1, or they will come from quadrant 4. But you notice that the angles will be measured in negative values. So it's negative 30 degrees, or negative pi over 6, all the way to negative 90 degrees, or negative pi over 2. If we were asked to find the arcsine value of square root of 3 over 2, So what we're actually looking for is an angle, and we have to pick from quadrant 1 or quadrant 4 since we're working with the inverse function. And we want to know what angle has a sine value of square root of 3 over 2, and that's a positive value. So when we look at our unit circle, I'm going to choose the point that has a y value of square root of 3 over 2, which will be here, and that's a positive value. And I'm only looking in quadrant 1 or quadrant 4. So the y values are positive in quadrant 1, so that angle would be pi over 3. So we could say that y is equal to pi over 3. So that would come from quadrant 1. For part B, when I'm looking for an angle, we have to look once again for an answer, an angle from quadrant 1 or quadrant 4. This time we're looking for an angle that has a sine value of negative 1/2. Well, when I look on my unit circle, a y value of minus 1/2 from quadrant 4 would be right here. Now the answer that we give has to be the negative angle. That would be negative pi over 6. So the inverse function would spit out negative pi over 6